Hi everyone. So in this video we will understand TLBO with an example. To know more about TLBO, that is teaching learning based optimization technique, you can refer to my previous video. The link you can find at the description. Very quickly we'll go through the idea of the TLBO. TLBO works in two phases, a teacher phase and a learner phase. A teacher is assumed to be a knowledgeable person. So here we are taking some variables to complete this phase. Here we have a population. Population here is a kind of number of learners or a students, and then we have a number of subjects offered to the student. Mij gives the mean result of the learner in the particular subject J at any iteration I, and then this refers to the K best is a best learner, and this value means the best overall result considering all the subject together obtained in the entire population of the learner. So in this phase, basically the teacher tries to increase the mean result of the class in the subject being taught by him or her. So here we calculate the mean difference by using this formula. This is basically the difference between the existing mean result of each subject and the corresponding result of the teacher for each subject. Here you can see some terms like TF. TF is basically a teaching factor. Teaching factor is used to decide the value of mean to be changed, and the TF is decided randomly by the algorithm, and it can take any value 1 and 2, and these value can be taken with the equal probability by using this formula. TF equals to round 1 plus RANG 01 to 1. So after finding this mean difference, the values are updated using this formula, and with the new values the objective function is again calculated. If the behavior of the objective function is assumed to be better, or you can say if you are getting the better values for the objective function, then these values, updated values, are considered for the next phase. Otherwise uh, the old values will be taken into consideration. So here we have teaching factor, which is not an algorithmic specific parameter, but it is decided by the algorithm at the runtime with an equal probability by using this formula. So we'll move to the next phase, learner phase. Learner phase is a phase where every individual, every element of the population gain their knowledge by interacting among themselves, or they can take the knowledge from the teacher. So here, this is the logic that is used to get the optimal result. So here, each learner, each element of the population, or you can say that each student, each learner has to uh, improve his value. Now this can be improved by interacting among themselves or by getting knowledge from the teacher. So each student will be interacting with each other to the other student. So we take any two students whose values are different, and if the f of xi is less than f of xj, then the values are updated by using this formula. Otherwise the values will be updated by using this formula. Keep in mind that this formula is applicable when the problem is of minimization nature. If the problem is of maximization, then this f of xi should be more than f of xj, and the formula remains the same. So let us move towards the example. So keep a note again, we keep on updating the values, but the updated value will be taken into consideration if it improves the overall objective function value. Here we are applying this approach on unconstrained optimization problem. This is a minimization function. This is basically a Himmelboi function whose value is known to be 0 for x1 equals to 3 and x2 equals to 2. It is worth noting that I have taken this example from the paper written by Mr. R. Venkata Rao, who proposed this, the idea of TLBO. You can get this paper from the DSL, and the name of the paper is Review of Applications of TLBO Algorithms and Tutorial for Beginners to Solve the unconstrained and constrained optimization problem. So let us assume we have population, and the size of population is 5. We have 5 students, or you can say 5 learners, and they are studying two courses, x1 and x2. So you can say this is our population, these are our design variables. So in the first phase, that the teacher phase, we will find the mean difference by using this formula, and here we have to use some random value. So for this example, let us assume that r1 equals to 0.25 for x1 and r2 equals to 0.43 for x2, and we are assuming the teaching factor equals to 1. So we'll find the difference mean for x1 and x2 by using this formula. We will use this. So this is 0.25. So this is 0.25, 3.22 minus 2.093. This is the mean value. So we are subtracting this value from this value, multiplying by r1, and this will gives you the value, new value of x1. Similarly, we can again do for this second student. For learner 2, we can write 0.25 into 0.191 minus 2.093. We calculate this, and this will be the new value for learner 2 in subject 1. Similarly, we will find the new value for learner 3 in subject 1. Similarly, we have to find the values for all the learners in subject 1 and subject 2. Now this new values will not show that the new values will always be accepted. It will depend that what is the impact of new values on the objective function. If the function is going to improve means, because this is a minimization problem, so if the value of the function is going to decrease, we find this value or the new score as a improved score, and we will take into consideration for the later iterations. So after getting the new values for each subject and then finding the objective function value, this is the new values of objective function we have achieved. So if you look at this, these are the new values, and these are the previous values. So this is, so here you can compare with the new values of x1 and x2. We are having the objective function values 13.3, but in the previous with this 13.13. So 13.13 is better than 13.3, so we will not take new values of x1 and x2 because this will not going to improve the function. Similarly, if you compare 94 and the previous is 77, again this is not going to improve. But if you look at this 14, 261, 43, you will find that these all values are going to improve. So we will not consider the updated values for learner 1 and learner 2, but for the other learners we will take into consideration the updated values because they are going to improve the overall results. So we will, so finally we'll move to the table 3, which is the improved result for all the learners. So here this is the overall improved values if you compare with the initial values. Now this is the initial status, and after completing the first phase, this is what we have achieved. Now this completes the teacher phase of the TLBO algorithm, and we will move to the learner phase, and these values are taken into consideration to do the calculations in the learner phase. In the learner phase, there are two ways of learning. They are learning from the teacher or they are learning with their peers. So to learn from the peers need to interact with each other, but when they're interacting, they have to keep in mind that the knowledge must have a different label. Then only one can learn from the other. So we will take two learners which have the different values in the courses x1 and x2, and they will uh, interact, and their effective output can be calculated by using this formula. So let us take some interaction that is going to happen among the learners. Let's say 1 and 2 are interacting, 2 and 5 are interacting, 3 and 1 are interacting, 4 and 5, and 5 and 3 are interacting. One thing to keep in mind, that when the 1 and 2 are interacting, so if you look at this, this is the table 3, which is the result of the teacher phase. So if 1 and 2 will interact, 1 and 2, so here you can see the value of the first learner is less than the second learner. So actually we are going to update, means the learner 2 will get the knowledge from learner 1. So we are going to update the values of learner 2, means we update the value of subject 1, subject 2 by using this formula. Similarly, if you look at 2 and 5, so 2 and 5 means this and this. So if you look at this, this value is not better than the value 5, means here the value of 5 is better than value 2. So this learner is going to learn from 5. So we are going to uh, update the value of learner 2. So in the interaction of 2 and 5, we are going to improve the value of learner 2. So for x1 and x2, we will be using some random values, like for r1 we have chosen this 0.47, and r2 we have chosen 0.33. So we'll use this formula, and how the formula can be applied. So here you can see the new value for x1 for the learner 2. So this is the formula to be used to update the values of each learner whenever this criteria is met. So here the value of 7 means sorry, so here you can see when we compare a learner 2 and learner 5, the objective function value of 5 is less than learner 2. So we are going to update learner 2. So look at this formula. The formula says the new value is equals to old value plus uh, random value and the difference in their values. So we will apply this into our calculation, and you will find here the values of learner 2 is calculated as, this is your old value plus the random number for x1 and the difference 2.495. So this is for fifth, this is for second. So 2.4975 minus this, and this gives you 1, and this gives 1.27423. Similarly, for updating the value of learner 2 for second design variable, for the second subject, we will take this and this old value plus the random value multiplied by the difference. So that is 0.31.058 minus 2.289, and you get this result. So similarly, we will be taking two learners at a time. We will compare their objective function value, and whichever is minimum will be used to update the other values. So every time the learners need to interact with each other, and the one who is having the higher objective function value will learn from the learner who is having the lesser objective function value. So we'll take 2 and 5, 3 and 1, 4 and 5, 5 and 3, and we will find the new value for x1 and x2, and then again we will calculate the effect of the objective function. If the new objective function is found to be better, then the values are acceptable, otherwise we will ignore this value. For example, after doing the calculation, means after interaction between 1 and 2, 2 and 5, 3 and 1, 4 and 5, 5 and 4, we get this new value and the corresponding objective function value. Here we have to decide that these new values are accepted or not. This we can done by comparing it with the previous result that we have obtained in the table 3. So this is your table 3, this is your table 4, and then we will compare, and you can notice that we are not going to improve if we update the value of learner 1, because it's already the better one than the new result. So we will not take the first value. If you compare with the second, third, fourth and fifth, then you can find that all other values are actually updated and gives a better result than the previous one. So here these values are all improved compared to the previous values of learner 2, 3, 4, and 4, but only learner 1 value is not going any improvement, so we'll not consider this result for the next iteration. So this is our final. Now, if you look at this table and if you compare this table with the table 1, we are able to make a comment that we are moving toward the solution, or are we able to improve our results or not. So here 1, that is the initial population that we started with. These are the different values with their effective objective functions. Now this is something that we have achieved after the learner phase, and this is the result. And here you can see that at the start, this is the best result we have so far in our population, but now you can notice here that it has moved to 12.3. That means after the first iteration of the teachers and learner phase, we are able to improve our result. If we go on with the more iterations, we can soon reach to the best value, that is 0, and that we can get for x1 equals to 3 and x2 equals to 2. So I hope you have understood that how the TLBO concept is applied to any problem. This problem is very effective if you're dealing with kind of multi-criteria optimization problems. So I'll take some more examples where the TLBO is applicable and giving better and improved results. Thank you very much.